All right, let's see how we can tune the hyperparameters of our logistic regression model using grid search CV. So grid search CV. Beautiful. And if we put a little note here, since our logistic regression model, now remember, it's quite confusing. I still look at this and think it's a regression model. This is a classification model. Provides the best scores so far. We'll try and improve them again using grid search CV. So if you want to look up the documentation for grid search CV, it's in scikit-learn. You can just search scikit-learn grid search CV, and you'll see it's an exhaustive search over specified parameter values for an estimator. So what we might do is just recreate different hyperparameter grid. So different hyperparameters for our logistic. And again, if you want to find the different hyperparameters you can choose from a machine learning model, in our case it's logistic regression, you could search something up like this. So how to tune a logistic regression machine learning model in Python. That's where we found things like what we're going to create here. So log reg grid, we've made this up here before, but we're just going to bring it down so we've got it in our line of sight. Log reg grid. So we'll just basically put in the exact same thing. So C equals np.log space -4 for 20 different spots. Actually, we might, just for fun, you know, we're going to increase this to 30. Because we're using grid search, why not? Why not live on the edge, you know? Create different hyperparameter spaces that we haven't seen before. That's what life is, exploring things we haven't tried before. That's where all the fun is. So we'll go setup, grid hyperparameter, search for logistic regression. We'll go gs log reg equals grid search CV. That needs a little capital there. Maybe we'll use tab autocomplete for this just because we're keyboard ninjas here. Now, the difference between randomized search CV and grid search CV is this little hyperparameter here. In grid search CV, it's just called param grid. In randomized search CV, it's called param distributions. So then we'll pass it this. Our new log reg grid, which has 30 intervals between -4 and 4 on a log space, because we are living dangerously here. And CV equals 5, and then we're going to go verbose equals true, just to put out our little outputs of what's happening. Now you'll notice there is no n-iter here, unlike in randomized search CV. There's n-iter because grid search CV tries every single combination of parameter in here and finds the best one. So we want to go fit. We've saved this, by the way, our logistic regression grid search to gs log reg, for gs is for grid search. So fit our grid hyperparameter search model, wonderful, gs log reg dot fit x train y train, and then we go boom, run. This is going to fit 5 candidates because totaling 150 fits over 30 different sets of hyperparameters, because we have set CV equal to 5, and it's done already because logistic regression is nice and fast. And so check the best hyperparameters and go gs log reg dot best params. Wonderful. Okay, so we've got a C value of that really long number. Solver is live linear. Well, we kind of guess that because there's only one option there. How can we evaluate this? We want to evaluate the grid search logistic regression model. So we'll use our test set again. So gs log reg dot score on our test data, x test, y test, and let's see. 88.5. Did we get any better? Come back up here. So if we look at our randomized search log reg, we got 88.5 as well. Are the later decimals different? No. They're the exact same. Well, it looks like our randomized search and our subsequently, I think our baseline logistic regression model got that same score. Subsequently, the logistic regression model has done very well. That's pretty good for a model that doesn't appear in this classification map. So scikit-learn, I think you guys need to put logistic regression in here because otherwise people are going to be missing out on it. So that's something to keep in mind, right? Is that although you find these maps and these cheat sheets online, it still helps to do your own research and not just rely on this handful of stuff that's going on here. Because remember, we know how broad machine learning is. Like, just look at this. There's just a lot going on here, but even within these little bubbles themselves, there's still more that can be done. So that's, I can't stress enough how important it is to try your own research. Okay, so now we've tuned our logistic regression model using grid search. We get the same results as before, even with increasing the number of different parameters that our logistic regression model was searching over. What we're going to do now is probably stick with this logistic regression model. We could spend a little while on this hyperparameter tuning, like going through different resources here, like this one here, hyperparameter tuning. We may be able to squeeze out another % or a couple of % of accuracy. But for now, we've got a few requests from our boss. Remember, she was telling us earlier, we need to have a look at the following. Hyperparameter tuning, feature importance, what's that? Okay, well, we've done hyperparameter tuning. We've figured out logistic regression is probably the model we're going to stick with for now. We've got a confusion matrix. We've done a bit of cross-validation through randomized search CV and grid search CV. We need precision, recall, F1 score, classification report, ROC curve, area under the curve. My goodness. All right, well, let's do it. So that's probably what we're going to do over the next few videos is use our grid search logistic regression, use our logistic regression model with its best hyperparameters that we found using grid search to get the things like the ROC curve, the confusion matrix, the classification report, the precision, the recall, the F1 score, and all those other classification goodies that you should use with every classification model. So maybe you want to try a few different parameters with grid search by searching up something like this. That can be a little extension, but otherwise we'll move on to the things that our boss is asking for us to make sure that we're reporting our results and our classification models correctly.